On this program, we will be dealing with household garbage, with the disposal of hospital waste, and the processing of pig slurry. Every year, the world's population produces enough waste to fill a train so long that its cars, one behind the other, would stretch from here to the moon. Today, waste collection has become routine, but it is only the first step in the waste disposal process. Our lifestyle is generating more and more household waste. We no longer repair appliances, we throw them out. The profusion of packaging seems endless. Some of the materials we use are difficult to dispose of. It's as if the industrialized world had only managed to solve the problem of waste collection. When it comes to waste disposal, the treatment facilities remain largely underdeveloped. The vast majority of household refuse is therefore never reused. At best, it is simply burned in incinerators. And for the most part, incinerators overheat and pollute the atmosphere. Worse, wastes are often unloaded in landfills, sometimes without any form of control. These open landfill sites constitute fire hazards. Indeed, the bacteria that decompose the organic detritus produce methane, a highly inflammable gas, not to mention the risk of polluting the groundwater and the air. In developed countries, the composition of household waste has changed in recent decades. The proportion of organic matter has gone down, while glass, plastic, paper, and cardboard have gone up. Modern society produces greater amounts of waste, and especially non-biodegradable waste material. Eliminating these wastes has become an acute problem. And yet wastes are not solely a source of hazards. They can in fact be sources of energy and raw material, as in this ultra-modern incineration plant, which is one of the largest in the world. Here the wastes are first upgraded by being converted into energy, a transformation that also makes it possible to recycle some of the byproducts. When the recycling trucks hauling domestic waste reach the plant, they are weighed and identified. Among other things, this allows the plant to bill the various communities for their waste collection, according to the amounts picked up. The trucks then proceed up the access ramp to the unloading platform, where they pour their contents into a pit. The pit will contain up to 6,000 tons of waste. The plant incinerates 2,300 tons a day, so there is seldom any buildup of waste in the pit. The three furnaces are fed by overhead traveling cranes. The cranes pour the refuse into the furnace's loading hoppers. Each furnace burns 28 tons of household waste per hour. The driving cab of the overhead traveling cranes is linked to the control room. Viewing monitors provide an overall view of the plant. The calorific energy that incineration generates is, for the most part, converted into steam. That steam fuels a district heating pipeline serving the equivalent of 70,000 homes. The remaining energy is converted into electricity. Energy recovery efficiency is thus over 80%. When it comes out of the extractors, the dross, that is the incombustible residue from the incinerator, is discharged on a vibrating conveyor belt. This cools it down, after which it is sorted to recover the scrap metal. Freed of its scrap metal, the dross will be used as a stabilizing underlay in the making of roads. As for the raw metal, collected in an electromagnetic drum, it will be recycled and sold to steel working plants. This type of incineration makes the most of the energy and base materials of wastes. It cuts their volume down to 10% of the original mass. It is important, however, that incineration plants be equipped with modern filters so as to process the fumes they generate. Burned waste produces hydrogen chloride gas and highly polluting heavy metal dust particles. This plant has such a smoke fume treatment system. First, dust is removed by precipitator. The dust particles go through an electric field. The negative ions, such as chlorides or sulfates, are drawn to the positive pole, while the positively charged metal ions are attracted to the negative pole. The next step is dechlorination by wet process. This process consists of watering down the fumes to solubilize the hydrogen chloride into hydrochloric acid. Some of the heavy metal salts, mercury in particular, dissolve as well. The sludge collected during this process is dehydrated and stored in specialized landfills. As for the wash water, this is treated in a neutralization tank before being sewered. Modern societies have to face the problem of the increasing amounts of waste they are producing and must find the technologies that will best preserve the environment. In all the waste modern societies generate, we often neglect to mention hospital waste. Germs, contamination, and bacteria are every bit as threatening as cardboard, glass, and plastic. Fortunately, there are effective technologies to neutralize medical residue. Hospital waste is on the rise, as are many other types of refuse generated by modern society. In hospitals, the proliferation of single-use products to avoid contamination is adding substantially to the overall volume of wastes. Waste that needs radical disposal is contaminated waste. Such waste is produced in hospital laboratories, operating areas, isolation wards, and dialysis units. Some treatment plants provide services to handle this refuse. These treatment facilities supply hospitals with leak-proof and easy-to-handle recycling carts. The assorted contents of these carts are completely isolated until their disposal. The hospitals are in charge of sorting their refuse and distributing it in various containers. Special containers are also provided by the reprocessing plants and are easily identifiable. Single-use products in non-woven fabric and waste that does not present a risk of infection or injury are collected in polyethylene bags. Wastes that are hazardous but not sharp-edged, such as compresses and dressings, are placed in waterproof containers. The latter are then compacted into sealed, resistant cardboard boxes. Sharp, contusive, and soiled hazardous wastes, on the other hand, are put into puncture-resistant containers sealed with zipper lock lids. As for the waste material that comes from the laboratories, it is enclosed in large containers that are both puncture-resistant and liquid and germ-proof. The carts containing septic waste are picked up within the walls of the hospital and exchanged for clean, disinfected ones. They are then loaded onto double-deck trucks that can hold up to 12 of them. The carts are then trucked to a domestic waste incineration plant. This plant is fitted with a special line for the disposal of hospital wastes. The carts containing the packaged hospital waste are brought into the reception area of the plant. A first barcode reading identifies the source and the date and hour of the cart's arrival at the plant. The waste is incinerated within 24 hours. At the beginning of the automatic handling line, an automatic reading of the same barcode records the weight and the date and hour of departure for incineration. This enables the plant to bill each hospital for the actual amount of waste sent to be incinerated. The carts are first conveyed to an elevator area. Each cart is then directed to one of the furnace feed hoppers. They're incinerated at a temperature of approximately 1,000 degrees Celsius, so as to ensure all pathogens are destroyed. This line eliminates 5,000 tons of contaminated waste annually. Devices ensure the dust removal and purification of the incineration fumes to avoid polluting the air. A system of video cameras relays the entire process back to a control room. Once they have been emptied, the carts are automatically directed to a washing compartment. They are turned over and thoroughly scrubbed with detergents and disinfectants. This waste is thus never touched by human hands. After draining, the carts are assembled in the reception area. While the carts are being washed, the vehicles used to transport them are also disinfected. Then the clean carts can be reloaded and taken back to the hospitals for further use. The total process takes less than 72 hours. This type of plant is also equipped to handle small amounts of waste. This is very useful in the case, for example, of hospitalizations at home. Unfortunately, whether the amount of contaminated waste is small or large, its treatment is expensive. Its disposal must therefore be strictly regulated, because the temptation to resort to non-specialized alternatives, such as landfills, remains strong. Farm effluents are another cause for concern. Long gone are the days of the nicely balanced plant-animal production cycle, when farmers recovered manure and slurry as fertilizers for their crops. New problems call for new approaches. Since industrial pig farming first began, the quantities of manure usually used as fertilizer has far outweighed the capacity of farmland to absorb them. As a result, in intensive animal production areas, pig slurry is a pollutant and an olfactory nuisance. In industrial piggeries, the animals are raised on slotted floors without bedding. They therefore urinate and defecate directly into a pit, and this manure constitutes what is known as pig slurry. Farms that house over 1,000 hogs are common. Typically, they generate more pig slurry than they are able to readily dispose of. A hog that weighs 100 kilos at slaughter is He's usually about 6 months old. It is estimated that during his short lifetime, he produces 0.7 cubic meters of manure, which corresponds to 5 kilos of nitrogen. It follows that 1,000 hogs will produce 700 cubic meters of slurry, 5 metric tons of nitrogen. At these levels, no one knows what to do with the excess slurry. The number of pigs raised in some regions is out of proportion with the amounts of slurry the local farmland can use. In cases like these, intensive animal production affects the environment in 2 ways. 1, the fermenting manure produces smelly gases, such as hydrogen sulfide and ammonia. And 2, the imbalance between the quantities of slurry used and the soil's nitrate needs entails a surplus of mineral salts. The leaching of nitrates by rainwater pollutes the groundwater supply. The water then becomes not only unfit for human consumption, but clearly a health hazard. As a substitute to manure spreading, a new approach, the biological purification of slurry, represents an attractive, environmentally friendly alternative. It is based upon biological nitrification and denitrification reactions. This process converts soluble nitrogen, which causes nitrate pollution, into gaseous nitrogen. Gaseous nitrogen, totally harmless, is the main constituent of the air we breathe. This kind of treatment eliminates 75 to 80% of the nitrogen from the manure. Techniques employed are similar to those used in urban waste treatment plants. The process begins by straining the fresh pig slurry to remove any particles larger than 0.5 millimeter, as they could damage the facility's pumps. The following operations are carried out in a reactor of sorts, that is a circular metal structure elevated on a concrete platform. The reactor comprises several compartments, each corresponding to a specific stage of the process. The first part of the treatment consists of oxygenating the slurry in an aerated tank for nitrification. During the airing phase, the nitrifying bacteria previously cultivated use the dissolved oxygen and carbon to multiply. They then convert the nitrogenous molecules present in the slurry in the form of ammonia into nitrites, then into nitrates. Second, denitrification occurs in a non-aerated tank in the absence of oxygen. The bacteria deprived of oxygen decompose the very nitrates they produced. This way, they obtain the oxygen they need to develop. They then transform the nitrates' nitrogen into a gas that is released into the air. The remaining nitrogen ends up in the biological sludge recovered in a third compartment by decantation. After dehydration, the sludge is spread locally or exported to a composting unit. The purified effluent is an odorless liquid, very low in nitrogen. It is stored in a lagoon, then removed by dispersion over cultivated land. Biological purification considerably reduces the chances of polluting groundwater and waterways. It also gets rid of the stench. This kind of facility also solves the problems of hog breeders who are unable to find sufficient land surfaces on which to spread the manure. The most promising solution would be to install such treatment facilities directly inside the compound. For the transportation of liquid manure, such as pig slurry, is not economically viable. Other factors can help to eliminate pig slurry pollution. For example, spreading the manure more in keeping with the type of plant cultivated. Indeed, all plants do not have the same nitrogen needs. Rape needs nitrogen the most, 200 kilograms per hectare. It is followed by the potato. beet and corn. On the other hand, such plants as legumes, which include alfalfa and soya, can go without nitrogen completely. They fix nitrogen in the air directly through bacteria that live in symbiosis with their roots. A better distribution of the slurry over the various types of crops would prevent excessive amounts of nitrate from percolating into the groundwater. At this time, when recessions and unemployment bite on the collective wealth, we can no longer tolerate that our resources be wasted. Our survival and that of the planet depend on it.